Assalamualaikum and hi to everyone. Hopefully you are in the right condition and the good condition. So in the previous part, we already learned about the scheduling. So this chapter, we will learn about the process synchronization. Okay. In this chapter 6, okay, we learn about the critical section problem at the synchronization hardware, the semaphores, monitors, the classic problem of synchronization. So how the importance of synchronization in process or execution at the CPU part. Okay, the main objective for this chapter is to present the concept of process synchronization to you. So hopefully at the end of the chapter, you're able to know the concept of the process synchronizations. Actually, synchronization is not only on the operating system, but most of the communication transaction we need the synchronization. The second, okay, to introduce the critical section problem whose solutions can be used to ensure the consistency of the shared data, because we have the data and we have multiple users and multiple users can access to the data, so we need to learn about the issues or problem regarding that part and how to solve it. Third, to present the both software and hardware solution of the critical section problem mentioned before, and then to examine the several classical process synchronization problem, as well as to explore the several tools that are used in order to solve the process synchronization problems. Okay, so we go for the first part. Yeah, the background study of the synchronization. So processes can be executed concurrently. Okay, we have the multi-threaded, we have the multiprocessor. That's why the processes can be executed concurrently in simultaneously. Okay, there is a possibility that the processes being interrupted at any time and only certain part, only the partial of the process complete to be executed. Okay, so may be interrupted at any time and partially completing executions. That are the possibility. The next, concurrent access to shared data may result in data inconsistency, because we have one data and we have multiple users that want to access the same data, so that will lead to the data inconsistency. How the data can be consistency? Okay, just I think we more clear if we talk about the money, right? If we more clear on that part. Yeah, we have 500 in our account, for example, and then in the same time, someone uh, deposit several amount money to your account, and before the process of deposit happen, you may withdraw your money. If we don't control the synchronization of those process, we have the data 500 in our bank, the amount may be lost somewhere else. That is how it can lead to the data inconsistency. Okay. Next part is maintaining data consistency requires a mechanism to ensure the orderly execution of cooperating processes. And then here we illustrate of the problem. Okay, let's say suppose that we wanted to provide a solution to the consumer and producer problem that fill all the buffers. Yeah, at this part we have two situation. One is for consumer, another one for the producer. So we can do by having an integer, which is the variable counter, in order to keep track of the number of full buffers. Okay, we use the counter to keep track. So initially the counter is set to 0, and we have consumer and producer in this case. So it is incremented by the producer after it produces a new buffers, and is decremented by the consumer after it consumes a buffer. Based on this situation, it's just like when someone deposit your account and you want to withdraw the money, there's no issue if do deposit first and then withdraw the money, and then the balance will be in the right way. Let's say you have 500, someone deposit 200, then should be 700, and when you withdraw 400, then should be the balance is 300. Okay, if we done the process one by one, how about the process simultaneously? Okay, you want to withdraw the money, you have 500, you want to withdraw the money 200. So supposedly your balance is 300, but before in the same process, the others deposit 200. So the calculation of your balance in your account may be incorrectly. So the same goes for this example. We have the consumer and we have the producer. Supposedly, if they work alone, one by one, then there's no issue. But if they work together in the same time, it might be an issue. There is a possibility. Okay. So here are the codes. Okay. While true, so counter is equal to buffer size. Okay, buffer integer, next produce. So increment 1, okay, counter plus plus. So we try to increment at the producer part, and at consumer part we will decrease the counter. So one increment, another one is decrease. Okay. Rest condition here, let's say it's being done in the simultaneous way. Okay. Counter plus plus could be implemented as register 1 equal to counter, register 1 equal to register 1 plus 1. So we try to do incremented and register 1 assigned to the counter. Okay, so now counter is equal to 1. Okay, let's say counter is set as 0. So now counter is 1. Okay, when you do the incremented, counter minus minus, so register 2 equal to counter is 0. Counter is 1, for example. So register 2 minus 1, so counter now is 0. That is the example, the logic way. But if the process within the same time, it's just a rest condition. Yeah, let's say time 0, the producer execute register 1 equal to counter. We set the counter fine. So now register 1 hold the value of 5. So at time 1, producer execute register 1 equal to register 1 plus 1. So 5 plus 1 equal to 6. Now register 1 hold the value of 6. At time 2, consumer execute. Okay, so register 2 hold the value of counter. So counter equal to 5. Consumer execute at time 3. So register 2 equal to register minus 1. So register 2 now hold the value of 4. And then after that, at time 4, producer execute counter equal to register 1. So register 1 is referred to 6. So now counter hold the value of 6. And after the producer execute, at time 5, consumer execute. So it execute counter equal to register 2. So register 4. So now the value of counter is not similar. one counter is equal to 6, and then after 6 is equal to 4. How about after the consumer execute the counter register to hold the value of 4, and then the producer execute the register 1 equal to counter? It might be a problem here. Okay, so we can identify that when we have one data and multiple process need to access the data, this kind of issue might be occur. So the next section is about the critical section problem. Okay, so we consider the system of n processes. Okay, let's say we have process 0, process 1, process 2, process 3, and process n minus 1. N processes mean the numbers of processes. So each process has a critical section segment of code. And process may be changing common variable, updating table, writing file, and extra. So let's refer to process. What are the process then? So when one process in a critical section, no other may be in its critical section. So critical section problem is to design protocol to solve it. Okay. Each process must ask permission to enter the critical section in entry section. So may follow the critical section with the exit section and the remainder section. Okay. There's a general structure of PI. So we have process, do, entry section, critical section, exit section, remainder section, while true. So these are the pseudocode or the algorithm for that part. Okay, to access the process 1, so do while turn equal to j, so go to the critical section, so j now assigned to turn and remainder section while true. So these are the algorithm for PI. For this critical section problem, the solution are mutual exclusion, progress, and bounded waiting. Okay, for the mutual exclusion, if process I is executing in its critical section, then no other processes can be executing in their critical section. So we need to have only one process in one critical section. So we call as the mutual exclusion exclusively. Okay. Number 2 is about the progress. If no process is executing in critical section and there exist some processes that wish to enter their critical section, then the selection of the processes that will enter the critical section next cannot be postponed indefinitely. Okay, we based on the progress. And number 3, bounded waiting. A bound must exist on the number of time that other processes are allowed to enter that critical section after a process have made a request to enter its critical section and before that request is granted. So we have the waiting time. So at the bounded waiting, assume that each process executes at non-zero speed. And no assumption concerning relative speed of the n processes, number of the processes. So we have the mutual exclusively, we have the progress, and we have the bounded waiting, means we have the waiting part. Okay, critical section handling in the operating system. There are two approaches depending on if the kernel is preemptive or non-preemptive. Okay, if preemptive means that it's allowed the preemption of the process when running in the kernel mode. If the situation is non-preemptive, means it runs until exit the kernel mode, block or voluntarily yield the CPU. So essentially free of the rest condition in the kernel mode. Okay, rest condition is referred to the counters issues before. Okay, on the next video, we will look on the hardware to support the synchronization. So until this part, supposedly you should uh, realize about what kind of situation that may occur when we try to do accessing to same data. Means we have many people, many users that want to access certain data, or we have many processes to be executed, okay, at one time. So later on, we will look on the hardware to support the synchronization. Fine. So that's all. Thank you and assalamu alaikum.